Hey, this is Ms. Delosier, and this is questions 31 through 40 on the long metabolism review. In photosynthetic cells, synthesis of ATP by chemiosmotic mechanisms occurs during, so this is basically saying, when do I make ATP using electron transport in photosynthetic cells? Do I make it in photosynthesis? Yes. Do you make it during electron transport for respiration? Yes, because plants respire and photosynthesize, so my answer is C. Why does it keep doing that? It's annoying. Anyway, 32. Reduction of NADP plus occurs during NADP plus reduced is NADPH. So that is what I'm doing. I'm adding a hydrogen. When does that happen? And it happens during photosynthesis. It cannot happen during respiration because remember, NADP only happens during photosynthesis. And it's going to happen not during the dark reaction. It happens during the light reaction. It's photosystem 1. So that's A. 33. Generation of proton gradients across membranes occurs during photosynthesis. Yes. Respiration. Yes. Both photosynthesis and respiration. Yes. This is the same question as number 31. So that's C also. The reactions that produce molecular oxygen take place in the light reaction, true. The Calvin cycle, false, because we're making oxygen during photosystem 2, the splitting of water, correct? Both the light reactions and the Calvin cycle, false. Neither the light reactions nor the Calvin cycle, false. The chloroplasts, but are not part of photosynthesis. That doesn't even make sense. So my answer there has to be A. Okay, so let's go on to question number 35. A flask containing photosynthetic green algae and a control flask containing water with no algae are both placed under a bank of lights which are set to cycle between 12 hours of light, 12 hours of dark. The dissolved oxygen concentrations in both flasks are monitored. Predict what the relative dissolved oxygen concentrations will be in the flask with the algae compared to the normal. I can't believe I put this on you guys' review because this would be an awesome test question. Okay, so I have one flask in the dark. Actually, I have one with algae and one without algae, so let me draw some algae. Okay, so this one is not doing photosynthesis. This one is doing photosynthesis, but it's also doing cellular respiration, you guys. So this one should have a constant, right? Because nothing's happening. But this one should make oxygen in the light. But what happens when it's dark? And we haven't really talked about that, but think about it. If it's dark and the algae is still there, it's not photosynthesizing, but it's still respiring. So what we're looking for is the dissolved oxygen to increase in the light and to decrease in the dark. So the dissolved oxygen in the flask with algae will be higher. During the day, that's true. The dissolved oxygen in the flask with the algae will be lower. That's false. The dissolved oxygen in the flask with the algae will be higher in the light, but the same in the dark. Maybe. The dissolved oxygen in the flask with the algae will be higher in the light but lower in the dark. Probably. The dissolved oxygen in the flask with the algae will not be different from that one doesn't make sense. So my answer here is D. I hope you got that one. If you didn't, you might want to send me an email tonight. Where do the enzymatic reactions of the Calvin cycle take place? The stroma. We've already answered that question like twice in this review. What is the primary function of the Calvin cycle? To fix carbon dioxide. My primary function, CO2 to sugar. That's my goal there, right? So not to use ATP, not to use NADPH, not to split water. My primary goal is to make sugar. So that's E. 38 and 39. What compounds provide the reducing power? I'd say this is asking you, reducing power, it's asking you who gives the hydrogen for the Calvin cycle. So where do you get a hydrogen from the Calvin cycle? ATP gives you a P, so that is not the answer. NADH is not in the Calvin cycle because Calvin is photosynthesis, right? So it's not NADH. NADH provides the reducing power for the electron transport chain in cellular respiration. This doesn't have an H, so it can't be that, so it has to be NADPH. See the H? Okay, so that's E. The NADPH required for the Calvin cycle comes from photosystem 1. We've answered that like 12 times also. And number 40. I'm almost done, Coach Wilhite. You can talk. Reactions that require carbon dioxide take place in.
Sign in.
Require carbon dioxide take place. So I need CO2. Do I need CO2 in the light reaction? No. Do you need CO2 in the Calvin cycle? Yes. Not the light reaction. Yes, the Calvin cycle. And the chloroplast is not part of photosynthesis is a stupid answer. So my answer here is B. And I will do the last 9 questions in a separate video.